Hey guys, so we're going to start with section 5.3, and if I was going to have you guys do this in class, I would have had you guys do a GeoGebra lab, which is what this discovery section is right here. So I still think you can do it, and I actually think it would be a good use of your time, especially since you guys have a lot of time. And I just think it'll be good for you guys to kind of discover and investigate on your own. But if you don't do it, that's absolutely fine. And we're actually going to start with this exterior angle inequality theorem. So we're kind of skipping the entire first page. Okay. So the exterior angle inequality theorem, we can use some background knowledge on this because we've talked about exterior angles before. Okay. And so what I want to do is just quickly recap what that is. So what I'm going to do is I'm going to draw a triangle up above. All right. You guys can just watch this. Okay. And I'm going to extend out one of those sides. All right. So what I just created was an exterior angle. So this angle right here is my exterior angle. And what we've talked about in the past is that that exterior angle is equal to the sum of the two remote interior angles. And so remember, the remote interior angles are the angles that are furthest away, that are non-adjacent to that exterior angle. Okay. So we're also talking about inequalities in here, which means that we're doing some kind of comparison, all right, between the measures of exterior angles and the remote interior angles, okay? So this definition is saying that the measure of an exterior angle has to be greater than the measure of either its corresponding remote interior angles, okay? And that should conceptually make sense to us, and I'll explain it in this example 1, all right? But example 1 is saying fill in the correct inequality symbol, which means that I'm going to answer less than, greater than, or equal to, all right, for these comparisons, okay? But if we look at this picture, angle 4 right here, all right, is our exterior angle, okay? Angle 1 and angle 2 are our remote interior angle, okay? So if we look at what this question is asking us to do, it's asking us to compare angle 4 and angle 1, all right? And based off of that theorem, it said that the exterior angle has to be greater than either of its remote interior angles, which means that angle 4 has to be greater than angle 1, okay? And when I say it should make conceptual sense to us, just take a look at what our regular inequality theorem, our regular exterior angle theorem is saying. It's saying that the measure of angle 4 would have to be equal to the measure of angle 1 plus the measure of angle 2. The only world where the measure of angle 4 would equal the measure of angle 1, all right, would be if the measure of angle 2 is 0, and that can't happen because it's an angle, which means it has to have a measure, all right? So angle 4 has to be greater than angle 1, okay? Same idea, angle 2 and angle 4 compared, all right, angle 2 has to be less than angle 4, okay? Now, example 2 is asking us to do the same thing, all right, only this time we're just looking at it as a full picture, okay? So example 2 is saying which of those angles have to have a measure less than angle 4. And we're not using the picture to help us in the fact that we're looking at like obtuse and acute angles. We're using the theorems that we've studied to answer this so that it's definite, okay? So we are looking at angle 4, all right? And angle 4 is going to be an exterior angle to this triangle right here, okay? And if you look, angle 1 and angle 2 are the remote interior angles. So based off of the inequality theorem, all right, angle 1 and angle 2 have to be less than angle 4. Now on part B, though, we're switching directions here, all right? And we're now saying, well, which angles have to have a measure greater than 7, okay? And once again, we're not talking about obtuse or acute, all right? We're using our theorems. So what I'm going to do is I'm actually going to highlight this triangle right here, okay? So angle 9 is the exterior angle in this figure, all right, in comparison to the two remote interior angles, which are 6 and 7, all right? Which means that angle 9, because it's the exterior angle, all right, has to be bigger than angle 7. Now, if I look at a different triangle, all right, this time let's look at the same triangle right here, but let's use this as our exterior angle, okay? So angle 5 would also have to be greater than angle 7 because, once again, it's our exterior angle to our two remote interior angles. All right, so angle 5. Now, the last one is if we've stated that angle 5 has to be greater than angle 7, angle 5 and angle 3, all right, are vertical angles, which means that angle 3 also has to be greater than angle 7. Okay, so I'm going to pause there, all right, and then we'll come back to this theorem 5.9 and 5.10.